Hello everyone, welcome back to my channel. In this lecture, I would like to discuss about association analysis, which is a very important data mining algorithm. Association analysis is all about understanding the association between different entities that exist in a given environment. To start with, in this lecture, I'd like to talk about the introduction part of association analysis and the problem definition of association analysis. We start with the basic concepts where we get introduced to market basket analysis. Market basket analysis is an association analysis where the different items in a big set of transactions in a given store are being analyzed. And then we move on to the problem definition of association analysis. Coming to the introduction of market basket analysis, we discuss a methodology known as association analysis, which is useful for discovering interesting relationships hidden in large data sets. It is going to be very useful in discovering interesting relationships hidden in large data sets. Now the question is, what are we going to do with the interesting relationships that are being discovered in large data sets? The uncovered relationships can be represented in the form of rules known as association rules. Now, let us look at an example of market basket transactions. Here we have an example. In this example, we have 5 transactions. In the first transactions, 2 items, bread and milk, are bought. In the second transaction, bread, diapers, beer and eggs are bought. In the third transaction, milk, diapers, beer and cola are bought. In the fourth transaction, 4 items are bought. In the fifth transaction also 4 items are bought. In association analysis, what we are trying to understand is whether the items that are bought in a transaction have any association among themselves, or are they bought together by chance. For example, let us look at the third transaction. In this transaction, milk, diapers, beer and cola are bought together. So what we are trying to understand is there any association between milk, diapers, beer and cola, or are they bought together by chance? After examining all the transactions in a given transaction set, we are going to come up with a set of rules. In this example, we can come up with the following rule as an example. The rule diapers to beer, which means that having bought diapers, what is the likelihood of the person buying beer? Or we can say that in a transaction, if a person buys diaper, we are going to understand whether the person is going to buy beer also or not. So this is what is the analysis that we are going to do in association rule mining. Now coming to the problem definition, we are going to discuss the following aspects. Number 1, binary representation of market basket data. Number 2, item set. Number 3, support count. Number 4, association rule. Number 5, why use support and confidence. And number 6, formulation of association rule mining problem. Binary representation of market basket data. Let us look at an example of market basket data which is going to be represented in the binary form. This is the example that we have discussed earlier. In this example, we can see that there are 5 transactions. Each transaction is going to have some items. The first transaction has bread and milk. The second transaction has 4 items. The third transaction has 4 items. The fourth transaction has 4 items. And the fifth transaction has 4 items. The same market basket transaction can be represented in the binary format as follows. So if you look at the first transaction, the transaction has bread and milk. In the binary representation, because bread and milk are bought in first transaction, we have a 1 in the binary representation for both bread and milk. Whereas there is a 0 for diaper, beer, eggs and cola because these items are not bought in the first transaction. When we look at the second transaction, bread is 1, diaper is 1, beer is 1 and eggs is 1 because these 4 items are bought in the second transaction. Similarly, for the third transaction, milk, diaper, beer and cola are 1. For the fourth transaction, bread, milk, diapers and beer are 1. And for the fifth transaction, bread, milk, diapers and cola are 1. This type of representation is called as binary representation. Binary representation is going to be very helpful when this transaction, market basket transaction, needs to be given as input to a data mining algorithm. Let us try to understand the word item set with the help of an example. Here we have an example that we have discussed earlier. In this example, market basket transactions, we have 5 transactions and a few items listed in each transaction. In order to understand item set, first we need to define the set of all items. Let I is equal to I1, I2, so on up to ID be the set of all items in a market basket data. In our example, there are 6 items in the set of all items, namely bread, beer, cola, diapers, eggs, and milk. We now define the set of transactions. Let T is equal to T1, T2, so on up to Tn be the set of all transactions. In our example, we have 1, 2, 3, 4, and 5 transactions. So this is the set of all transactions. Now we try to define item set. In association analysis, a collection of 0 or more items is termed an item set. So for example, a collection of items bread and milk is an item set. Now we define the next term, which is k item set. If an item set contains k items, then it is called a k item set. So the item set which contains bread and milk is called a 2 item set because it has 2 items in the set. So therefore it is called a 2 item set. So now we move on further to define a transaction which contains item set. A transaction Tj is said to contain an item set X if X is a subset of Tj. For example, the transaction 5 has or contains an item set bread, milk and diaper because this item set is a subset of the transaction 5. So that is the reason why this item set bread, milk and diaper is contained in the transaction 5. Now let us try to understand support count with the help of the same example that we have seen earlier. So this is the example that we have seen earlier. Now we try to understand what is support count. Support count is an important property of an item set which refers to the number of transactions that contain a particular item set. Let us look at an example. Let us look at the support count for bread. The support count for bread is 1. Transaction 1 has bread. The support count for bread The transaction 2 also has bread. Then the transaction 4 also has bread, and the transaction 5 also has bread. Therefore, the support count for bread is 4. Now the support count is referred to as row of x. So therefore, the support count for bread is row of bread, which is going to be equal to 4. Now mathematically, the support count, which is row of x for an item set x, can be defined as follows. Row of x is equal to the number of elements. This symbol denotes the number of elements. Number of elements or number of transactions such that the item set is contained in Ti, and Ti belongs to the set of all transactions. So now let us look at an example. Let us look at the support count for an item set milk and diaper. The support count for milk and diaper in this example is milk and diaper is found in transaction number 3, number 4, and number 5. So therefore, the support count, which is a row of x, where x is the item set, x is going to be equal to milk and diaper. The support count for this item set is equal to 3 because it is the set of all Ti. The set of all Ti are 3, 4, and 5. In these three transactions, the, the set of items, the item set milk and bread is found. So therefore, the support count for the item set milk and diaper is 3. So this is how the support count for an item set is defined. Having understood what is support count, now let us try to understand what is association rule. An association rule is an implication expression of the form x to y where x and y are disjoint item sets, which means x intersection y is phi. For example, let us assume the item set x as milk and diaper. Milk and diaper. The item set y is, let us assume, going to be beer. So now an association rule, which is an implication expression, is going to be milk and diaper to beer. What we are trying to understand here is someone having bought milk and diaper, how likely is he to buy beer? That is what we are trying to understand. If someone having bought milk and diaper is very likely to buy beer, then the association rule is going to be very strong. Someone having bought milk and diaper, let us say, is not likely to buy beer, then we say the association rule is not very strong. So now we need to understand the way in which the strength of an association rule is being identified or is being found. The strength of an association rule can be measured in terms of its support and confidence. Number one is support and number two is confidence. So now let us try to understand what is support and what is confidence. So the definition of these metrics, which are support and confidence, are as follows. So the first one is support. Support s of x to y means an item support of an item set x to y is rho of x union y by n. We already have discussed that rho of x union y is the support count of X union Y. In this case, in the example that we have discussed, where we are talking about milk and diaper being X, the item set X, and bear being the item set Y. In this example, row of X union Y is going to be the support count. Row means the support count. Row of the set, row of the set milk, diaper, and beer. Means the the number of transactions, the number of transactions which are going to have milk, diaper, and bread divided by the n, which is total number of transactions. This is how the support of x to y is found, or is calculated. Now coming to the second one, which is confidence. Confidence of x to y, which is C of x to y, is going to be equal to row of x union y by row of x. Means the support count of x union y divided by the support count of x, which means the support count of the set consisting of milk, diaper, and bread, which is and beer, which is the set x union y divided by the support count of the set consisting of milk and diaper. This is the way in which support and confidence of an association rule are measured. Once the support and confidence of an association rule are measured, then we understand the strength of the association rule. So now let us calculate the support and confidence of the example that we have already discussed now. Now let us look at an example to understand how the strength of an association rule is calculated. So as an example, we take the same market basket transaction example which have been discussing throughout the lecture. So what we are going to do here is we are going to take the association rule milk, diaper to beer. Here milk, diaper is considered as the item set X and beer is considered as the item set Y. So therefore we are going to calculate the strength of the association rule X to Y. To calculate the strength of the association rule, first we need to calculate the support of the association rule. In order to calculate the support of the association rule, we need to understand the support count of the set X union Y, which is milk, diaper, beer in this case. So milk, diaper, beer is X union Y. So we need to calculate the support count for this, which is denoted by rho. So therefore the support count of X union Y is, as we can see in the example, the transaction 3 has milk, diaper, beer, and also the transaction 4 has milk, diaper, and beer. So therefore the support count for milk, diaper, beer is 2, and then the total number of transactions is 5, as we already know. So therefore the support is going to be counted as row of X union Y, which is the support count for milk, diaper, and beer, which is 2, divided by n, which is the total number of transactions, which is equal to 5. So 2 by 5 is going to be 0.4 or 40%. This is the way in which support is calculated. Now we'll go to the next one, which is the calculation of confidence of the rule. The calculation of the confidence of the rule is done by first taking the support count for milk, diaper, and beer, which is going to be row of X union Y, row of X union Y, which we already know as going to be 2, and this is going to be divided by the support count of milk, diaper, which is going to be x. So therefore, rho of x union y divided by rho of x. So the support count for milk diaper is 3. As we can see, milk and diaper are found in transaction number 3, transaction number 4, and transaction number 5. So therefore, the support count for milk and diaper is 3. So therefore, the calculation of confidence is going to be rho of x union y, which is going to be equal to 2, divided by rho of x, which is going to be equal to 3, which is equal to 0.67 or 67%. So this is the way in which support and confidence of the association rule are calculated. We now move on to formation of association rule mining problem. We first define association rule discovery. Given a set of transactions T, we find all the rules having support greater than or equal to minimum support and confidence greater than or equal to minimum confidence, where minimum support and minimum confidence are the corresponding support and confidence thresholds. We therefore understand the fact that the problem of association rule discovery is divided into two parts. The first activity is identifying all those items whose support is greater than or equal to a predefined minimum support, and then from those items identifying all the items whose confidence is greater than or equal to a predefined minimum confidence. So therefore, to improve the performance of association rule mining algorithm, we decouple we decouple the support and confidence requirements. So the activity of decoupling this support and confidence requirements is done by decomposing the problem into two major subtasks. The first task is called as frequent item set generation. The objective of this task is to find all the item sets that satisfy the minimum support threshold. And those items which satisfy the minimum support threshold are called as frequent item set. And the second subtask is rule generation, whose objective is to extract all the high confidence rules from the frequent item sets found in the previous step, which is frequent item set generation. And these rules are called as strong rules. With this, we come to the end of this lecture. In this lecture, we have tried to understand the basic steps involved in association rule analysis. And I'll come back with my next lecture where we'll be able to discuss about frequent item set generation and rule generation. Thank you. Thank you very much for your patient listening to my lecture.